This is something I've never seen before. Yes, it's a Harrier CBHQ base station, but it's in the factory original box. And I've not even seen one when they were new, because obviously if I'd have gone into the shop I would have seen one new, but I've never seen one come in for service still in its box. And now 38 years later, we've got this. See if we can show a bit more box. There you go, the CBHQ box. We'll put that back to the normal position. It's come from another dealer in Wales. Please find enclosed one Harrier CBHQ base station and factory mic. This was bought very recently through eBay and used for a few days before the lady started to receive reports of squelching noise received by other operators during initial TX. So he's done the VCO, he's done the power supply. We'll probably do the capacitors in the power supply. And then he's found it's got a CPT 80 channel board in it. And of course that isn't legal, and legality aside, they never work properly anyway. Well, certainly none of the ones we've ever seen. I just don't get the point. You know, you've got, it's a bit like saying I've got this 1937 Rolls Royce, but actually we've managed to hacksaw the dashboard and put a CD player in it. Yeah, right. So we'll open this radio up. And it's brave to send it in a packing in original box, but of course it's the best way to ship it if it's got any of the original packing materials, which I don't think it has. Right, how do we get this out? Well, there's the mic. I'll research this in a bit and see what she paid. Because these days they've got to be 95 quid plus, haven't they? Well, that sleeve certainly it's original. Good grief, I'll be tickling the camera's ribs to get to this. Right, I better put the box somewhere well out of the way. So, serial number 2594. Yeah, and it's got somewhere, of course it's got somewhere, but it's got the original box. So the first thing we're going to do is see what we are greeted with. And one of the snags with not wanting to take on the removal of a modification board is you're not quite sure what they've done. Our success rate in removing them isn't 100%, because sometimes that board has caused damage to the radio, which is, shall we say, beyond economic repair to get to the bottom of. But luckily this has kind of come in before it's totally failed. This has got those strange screws in which we don't know what they're called. Those strange screws that have got a plain bit and then the, I think it'll be M4, won't it? I think we'll do the power supply capacitors. I've no doubt we'll have to take the bottom off, so that'll be another million screws, but I told myself a zillion times not to exaggerate. I'm doing this on Sunday, trying to do this between church services. It's currently 11:45. I'm hoping to be able to do 15 minutes of this right now. I've got service this afternoon. These things have to be prepared for, and then you kind of, by the time it gets to having done 2 of them, it's a bit too tiring to carry on doing things like this, especially if you've got to think about it. So tomorrow, Monday, is when this is scheduled to be done. but these are the wrong screws in the top. But we're delivering that base station personally, the Harvard H404, which the gentleman purchased. So it's going to take, you know, all the time, all the spare time tomorrow to do that. That's got a bulge in it actually. So behind the front panel, he says. So yeah, the chip's missing. Yeah. So there should be the synthesizer IC there, and that's missing. So $14.99 for one of those chips. Let's hope it's been put on that board, because that instantly adds the cost of that. Not that easy to get these days. I mean, it's 38, 39 years ago, isn't it? So we'll whip a pile of... I used to have an electric screwdriver, but you know what? I've gone back to standard ones. I'll put the soldering iron on, because obviously that board's got to come out. And then we've got to discover what they've done to the switch, because if it's got, is it tone switch? If they've done it on the tone switch, have they taken the tone correction capacitor out? And you know, do I have to research that? Might be in several parts by the time we've done it. I don't mean the radio, the video. Yeah, so the tone correction capacitor has gone, and this is going to mean we'll have to drag out another one of these to find out what's there, because we don't have a service manual. I don't think that I wrote to Harrier at the time, to Dixon's group, and they never even responded to my request for service manuals. The best company, believe it or not, when I wrote to Rotel, I'm going back to 1982, I wrote to every single company. Some of them never existed. You know, you look through the CB magazines, and some were pre-production prototypes, like the 10-Vox Voxon that never happened. The Ham International Hercules base station never happened. It was available as a CPT only for CPT countries, but it never happened here. And Rotel sent me the 3 manuals I asked for, 220, 230, 240, free of charge. Amstrad, I think it was a token price of $1.90 each, and you know, Binatone with no problem at all, Fidelity no problem at all, but Harrier no. Now I can see we've had something's happened with the wiring on this mic connector. So why would anyone do that? Anyway, we'll start by removing that IC, and we'll... not IC, the subboard. So it's not the best bit of printed circuit board down there. When that original chip was changed, there's 1 or 2 tracks have got damaged, which isn't surprising. So what we're going to do, for a start, is we'll go over with isopropyl alcohol and clean up, so I can really see what is and what isn't there. Then the board which is taken out is obviously quite recent. It's not something which has been in there since 87. I've not seen this before. A 4G16034QLB, no idea, but it will look nice when it's cut in half. I think we'll recover that trimmer capacitor off it though. So get on the isopropyl alcohol and we'll see how we can progress with that. So before we start putting the new device in, and these are coming now with quite tarnished pins. They're really taking some cleaning the 38-year-old chips. So I've just cleaned one up. So we've cleaned all the pins out, used the isopropyl alcohol, and you can see we've got track missing that should bridge across, so we'll have to deal with that. And there's quite another where the tracks are not really there. So let's see if we can put it in. You know, when things go wrong here, I tell you about them as well. So took the silly board out, put a new £14.99 phase lock loop chip in, and powered it back up, and I couldn't get it to do anything, get it to lock. It was 6 volts all over the place. And you know, you're in trouble with these, when people have messed about with these things, you don't know what they've done. And what they've done is they've taken the Zener diode out, which is just down there. It's a 6.2 volt Zener. So of course I powered it up without the 6.2 volt Zener in, and then without that voltage regulator you've got about 8 volts going into the synthesizer chip, so that was the end of the new synthesizer chip. So I've just put another Zener diode in, and I've just put another synthesizer chip in, and of course that's not the customer's fault. That's one of those things that happens, and that's, you know, that what little bit of profit there could possibly be, which I doubt, is now been really wiped out by doing that. This is why people can be reluctant to take these kind of things on, because you don't know what's happened. So we should be back to a normal radio now, and we'll now try and set the VCO. As ever, I can never remember the details, so we'll just look at the service band. I think we know it's channel 40, and I think it's 4 volts it is. So I've just done that because I didn't want to start the video and other things were amiss. So we'll just show you, I'm on channel 40, we'll go to the test point, which is the end of that resistor, and we've got 4 volts. Now this is where I haven't done any further. So I'm now going to press transmit, we should also have 4 volts. We've actually got 5.6, so we need to bring that down with the trimmer. Now it is interactive with the other one, and we've still got 4 volts. So that's receive, that's transmit. Let's put picture in picture on so you can see that. That's transmit, and that's more than full scale deflection on my meter. Now no doubt it'll be off frequency because of it being back to the proper synthesizer chip. So what we'll now do is put the camera on the frequency counter, and we'll press transmit again. 2799. What? Oh, it's channel. Yeah. Do you know what? I've missed a stage out, haven't I? I've not checked the channel 1. So, but we'll do this first. We'll do the frequency first. So back to channel 20. 27990. It's always channel 40. Oh. 2760125, I think that should be. Back to 20. Should be 2779, what it is. I wonder if we've got a dirty contact. Oh, thank goodness for that. I was thinking, what on earth is happening now? So it's 2779125 it should be. So we'll just adjust the trimmer, which is just hiding below the crystal. So there we are, 2779126, that'll do nicely. So I'll just check channel 1. 2760125. And now we'll just check that VCO voltage. That it needs somewhere around 2.5 or something, isn't it? Yeah, so that's our receive one, that's our transmit one. So we're absolutely fine. That's fine. So thank goodness for that. Oh. So if I ever see one of those horrible little silly boards again, I'll know that they've taken the Zener out. Right, let's have a look at the power. So we want to try and get 4 watts out of the radio. And it's actually doing 3.9 watts, so that's fine, but we need to optimize it. So we need maximum on this coil, maximum on this one, and then with the green tool, which I can never find, we need to put maximum on these. Oh, that's a bit stiff. I'm not sure whether that's moving. That's full. What on earth's happened there? Core's missing. Oh, so broken that what I'm going to have to do is to find an Allen key just to, well, turn the power off, just to move that one. And we're going to have to unsolder this coil and to actually take the thing out and see if I can find a core out of a scrap set. We'll pause the video. Right, back on to record. I've had to replace the cores in both the yellow one and the green one. So we'll key it once again and see where we are. Helps if we switch on. I've just realised I've tuned the whole thing up on channel 1, so we'll start again. So maximum, maximum, maximum. So it's 3.9 watts we've managed to get out of it with broken cores. That was the point. We know that we've got that one at peak, so we'll bring that to where it needs to be, hopefully. So that's now 5. Just peak these again. 5. 5.5. Okay. Now then, the clever bit. Rotate L4 clockwise for 4.4 watts. That's there. Rotate L9 counterclockwise. They say for 3.8 watts, but we're going to set it for 4 watts. There we go. And then we check that it's within about 0.1 on the top channel, channel 40. We're spot on 4, and on channel 1 we're spot on 4. So I've balanced that absolutely 100%. I wasn't going to look at how they'd got it before because it was broken. But of course we have to have scrap sets to get cores out of, and they are diminishing. I've not had any radio rallies this week. That's the remains of one of them. So they'd managed 3.9 watts, but I bet it was really lopsided. Anyway, that's transmit done as far as that goes. So I need to check low power because I want that to be 0.4 of a watt. Every time I come up to one of these, the preset's dirty, so we'll spray that before we even try it. So low power, switch to that, and it's doing 1.4 watts, which is no good for low power, so we'll pop that down to where it should be at 400 milliwatts. So we'll go back to full power, And now we need to set the power meter on the radio so that it reads 4 watts or whatever the meter's calibrated at. So it's banging across, so we want that to read 4, which it now does. That wasn't that far out, to be honest. Deviation. Wallow. 3.5. Well, that's really clever, isn't it? Right. So we'll need to set the gain one to center. That's right at one end. And then the other one to about there probably. Wallow. Spot on. So we want it to be around about 2.2 with average speech, with an absolute maximum of 2.5. And wallow, we've got that. And a wah, it's a 2.5. So that is that. You know what? I think we've done the transmitter now. Let's hope the receiver is a bit better. So we're now listening to what? That's 0.3 of a microvolt, which it is resolving. So plug the instruments in. And the first thing we'll do, well, first of all, I think we'll just read off what the synad reading is at the moment. So let's set that to there. It's 0.3 of a microvolt for 12 decibel synads. That's excellent. We'll probably get a little bit better out of it when we've tuned it. Right, so what we'll do, we'll put a S9 signal in 100 microvolts. We'll look at the oscilloscope. We'll turn the bench lights off so you can see the oscilloscope. And we'll turn the volume down till I get the right size waveform, because I can't be bothered to adjust the controls on the oscilloscope. And we need to launch in on the detector coil. So we're wanting maximum recovered audio. And it was already spot on. Okay, now we'll deal with the synad. Whoa, you get the extra receiver stage on this model. Don't have that coil on most sets. So put it about there and see if we can get anything else out of it. The answer is yes. We'll go through those again. Then we need a bigger signal to do the next two. I think that's very good. Let's see what we've got now for 12 decibel synad then. Oh, we've got 2.7, so we gained a little bit there. I'll show you the attenuator controls. So we've got 0.3 scale and we're at 0.252627. Good. Right, we'll calibrate the S meter. So an S9 signal, it's 100 microvolts and the meter should read S9. Why does it keep going off? It's on the plus of plus 30. So that's the adjustment. So we're on exactly on the 9. And that leaves us with the squelch. And the squelch, we'll turn the squelch on the radio to full, and now we'll advance the attenuator because we want the squelch to come in at S9. That's 10 microvolts, 30 microvolts, 100 microvolts. We want the squelch in, so we'll just control till it comes in. There we go, and it comes in at S9 every time. So that should be set, but just to check it, we'll turn the signal generator to standby, turn the squelch right down, set threshold, switch the radio signal generator back on, and see when it comes in now. So it's coming in at 0.65 of a microvolt, it's leaving it 0.6 of a microvolt. So that seems sensitive enough. That's it. Now I've got something intermittent on this radio, and it's going for a little sometimes off, isn't it? So we'll put the big signal back on. Something is happening. Sounds like it's on the channel selector board, to be honest. So I'll tell you what we're going to do as a test to prove whether it's the selector board. We're going to switch to channel 9. Oh yeah, how come we're still receiving? Have they disabled the channel 9 switch? Yeah, they've disabled the channel 9 switch. We know they've disabled. So we've got things to do to this. I was hoping to be able to put the video out today, but it's not going to be. It's already 8:30 and I've done enough. So we'll start again on this tomorrow. And there's been some soldering on this channel selector board, which isn't unusual. We've got to find out where the channel 9 wiring goes. And we're going to have to find out what capacitor does the tone on the tone control switch. I'll probably have to take the bottom of one of my own Harrier CBHQs to see what's happened here. Again, it's all more work when these kind of things are being messed with. So at least the radio is back working, and we'll start again on this tomorrow. So moving on to the next day, I've dug out one of our CBHQs. I think this is the one that's going to be going in my radio van as our base station for CB in there. So I'll zoom out a bit, and so this is the whole reason we have this business model, and that is to have one of each set ever made. Because when we're stuck with a set like this, customers, how do we rewire that channel 9 switch? There's no service manual available, so we need to look at another set. And we need to look at another identical set, because those front panel features will vary from set to set. So we have absolutely nothing connected to the customer's tone control switch, and we know that the channel 9 switch isn't producing channel 9, but is of course putting 9 on the display, because we saw that. We need to look at that wiring. So looking at our own set, okay, this clearly has been in a smoker's house, everything's a little on the brown side. So one of the things which isn't excellent in the customer set is the mic wiring. Somebody's messed with it. And what we can see here is we have a capacitor which does the tone correction. So you'll switch in that capacitor to make it more bassy. So we can see the wiring for that, and I'll be able to make some notes. We can also see the wiring for the channel 9 switch. So we know that half the switch is wired right in the customer set because it throws up the channel 9 on display. But the actual other one that does the 9 itself, where it addresses an individual pin of the LC7137 synthesizer, which is an instant channel 9 pin, we know that wiring must be missing because the nasty 80 channel board which was in doesn't have that kind of facility. So I'm going to make a note of the wiring colours. We'll measure what that capacitor is there. Might be able to do that right now on video. Make sure the switch is in the out position. If we hook this onto the lead of that capacitor, I wanted to get on with another set today, because to spend so many days on one set, and we only have 2 40-minute time sessions a day for CB radio, it just means that the repairs which are in are more and more behindhand. 10 nanofarads, so that's fine. So that's 0.01 in English. 10 nanofarads it is, no problem at all. So if we look at the service manual for the Rotel 240, that's going to have tone correction, but done in a different way. Let's have a look. RF gain, volume, channel 9, mic gain, dimmer, attenuator. Yes, tone, and it says it's 0.01. So it's exactly the same. So that's fine. So we'll get a capacitor of 0.01 and we'll put that in, and we'll put the wiring back which is missing by copying our set. So the manual for the Rotel 240 does verify that. So I'm going to write down those wiring colours, and then we'll transfer that information across to the customer set, and then we'll put mine back together. Okay, so we've got that all working. So now when I flick to channel 9, as before the radio displays channel 9, it always did do, but now when I press transmit, we have 2768125, which is channel 9, and of course it receives on that too. And then if we go back to normal channel, which is channel 20, and now when I flick the tone switch, low, high, so that switches in that capacitor. So I'll try not to touch the mains wiring, but turns out this is messed around with because the socket's either been replaced or turned around, so the locating pegs the opposite way to normal. There's no reason to change that back, but that's why the wiring's a bit mashed up. So there's the extra capacitor, which is 0.01 microfarads, 10 nanofarads. The blue wire, which goes to the volume control, I've put a join in it. I found a scrap AM Cybernet radio chassis which I was able to take identical blue wiring off. As it happens, the black wire, which also goes to the volume control, hadn't been cut too short, so that was okay. And then we traced the wiring to the underside of the printed circuit board and put the channel 9 to the active pin. I think it is pin 9 which activates channel 9, strangely enough. So I'm just going to clean that up with isopropyl alcohol, and then we can put that back together, and we'll conclude this video by the usual flicking round on the channels to find nobody there. Okay, so we've got it to the conclusion now, and just put the right camera on. Guess there's a light behind there. 19 a Roger. I better turn the RF gain up a bit. $19 a Roger. And if we listen to that on our own monitor receiver, which I'll just switch on and turn the signal generator off. Testing 1 2 3 4 5 1 2. There we go. So we're doing on the air test for that tonight, and then it can go back to the customer, who is a dealer, and then it can go back to the actual customer. So pity they bought a disappointing set. I don't know, these 80 channel brigade people seem to think they're doing something good, and they're not, because it didn't work properly, and there we are. So I'm going to have lost money on that, but it means that ultimately the customer gets a good radio, and that's what it's about. So thanks for watching the Harrier CBHQ, which is going to a dealer in Wales.